Hello, welcome to my virtual JuliaCon poster talk on StandardizedPredictors.jl. So in order to build quantitative models from data, we need to transform that data into some kind of usable representation. A common example of the sort of transformation you need to do is to take a categorical variable like a string and convert that into some kind of numerical form. But even variables that come already in a numerical form need some love too sometimes. They can come in very different scales and with varying non-zero offsets. So these kind of non-standardized predictors can cause problems, both with by introducing numerical instabilities in the procedures that are used to fit the model, and also introducing subtle errors when interpreting the model. And so some of the common problems that can arise include unnecessary collinearity between the predictors, which can lead to variance inflation, especially for non-centered predictors, and things like misleading coefficients in linear models that include interactions. And so standardization is a common part of the modeling pipeline, but it's easy to get it wrong or to introduce errors by doing it manually. So what StandardizedPredictors.jl provides is a convenient set of convenient and safe wrappers for common methods of standardizing continuous predictors. And these are compatible with StatsModels.jl, the formula-based domain-specific language, and other models that build on top of that. So things like GLM.jl or mixedmodels.jl. And currently we support centering, so removing an offset from a continuous predictor. Other standard methods of standardization are planned, such as z-scoring and scaling. And the way this works is that StandardizedPredictors.jl includes a wrapper type for terms that carries around the standardizing parameters, and then will carry out the standardization transformation lazily just before handing off the numerical representation of the data to your model. And these wrappers allow both for manual specification of how to standardize predictors, as well as automatically guessing based on the data if no manual specification is provided. And so these are sort of analogous to the categorical term type that's included in the base StatsModels.jl, where the categorical term carries around the contrast matrix that tells how to convert each level of the categorical variable into a numeric vector, and then does that conversion just before handing off the data to the model. Okay, I'll see you at the poster.